Good morning, everyone. I'm Geetha Sethuraman. I'm from Cognizant. I had delivery in North America for our data and analytics work that we do. And I've been with Cognizant for over 25 years. It's been a long journey. I started off with Cognizant, and I've worn various hats in my journey with Cognizant. And I've done sales roles, pre-sales, solutioning, and delivery right now. I had delivery for a variety of our customers across various business domains. With that, let me get to the topic. Let me ask this question. If I may ask people in this audience, how many of you are happy what you're paying for your cloud infrastructure and are not looking to reduce the cost? And you're not looking for opportunities to accelerate the performance of your workloads. Anyone here? Show of hands. Well, I thought if there was anyone, I would have gladly asked you to talk about it and I would have relaxed. So that's the situation here, right? Whatever we're seeing here across among us is what we see among all our customers too. All of our customers predominantly are looking to optimize their operational spend, and they are looking for ways to reinvest that money in actually building more advanced analytics that can enable their business and fuel their business. So reducing the spend and turbocharging the performance of the engineering workloads is key. So how did we land in this scenario? When the cloud migration journey started, it was a big shift from CAPEX to an OPEX model. So clients thought that when they start moving their workloads to the cloud, it will be a gradual increase in the cost, and then over time it will stabilize, and then they can be well within the budget. But in reality, this is how it typically ends up being in, right? So the moment clients brought their workloads onto the cloud, there's a sudden spike in the usage. Just because of the simplicity with which the workloads can be run on the cloud, there is heavy usage, and there is also this elasticity around the compute and storage that makes the usage go up, and then people are not having that mindset to be fiscally responsible, and there are no best practices around making sure that you are fiscally responsible on the usage. So obviously the costs go up. So you can see that curve going up there, and you get into this oh no moment. Oh man, the cost is going up. Then there's a knee-jerk reaction of trying to put some measures in place to put down the cost down. Then suddenly, as more and more users come on and more workloads come onto the cloud, again it spikes up. So this is a continuous up and down curve. So there are some controls that are put in place, but there is not a solution that is essentially looking at maintaining the cost below budget. So this is where our spend management offering comes into the play, and so this is a very holistic framework that we have. And before we talk about the framework in itself, when you talk about Databricks, there are lots of considerations that we have to have in mind. The cost on the Databricks itself, and then on the cloud cost. So talking about the Databricks cost, if you look at some examples of what we have there. So for example, should I use a photon-based engine for across all my high-end environments and the lower-end environments, or should I just do it on the high-end environments? Even if I do it on the lower environments, it's going to be pay-per-use. Or what should be my caching strategy? And there are questions like, if I'm running the workloads and the processes themselves are not optimized, it's all going to be suboptimal, right? Or if the data quality is not good, how much ever I optimize the compute, the resultant data is not going to be useful. So the partitioning strategy and so on. There are so many such considerations that play a pivotal role in managing the costs of Databricks and your cloud. Likewise, if you look at it from the cloud cost, the storage, the network, the compute, am I using the data with the right data formats? Am I utilizing the features like data skipping, reducing the amount of data that is being cached, so on and so forth. All this play an important role in, and all these considerations and questions are very key for us to determine how can we manage the cost. So now, coming to what's Cognizant's offering here. So this is a very holistic, comprehensive framework that approaches spend management with a holistic approach on 6 different dimensions. There are 2 vectors on which we look at it. The first and foremost, the first step is to observe and optimize. If you cannot observe, you cannot optimize. So that's the fundamental step. And the second step is, how do I turbocharge the performance and slash down the cost of my compute? So these are the 2 tenets on which we approach our offering. And when I deep dive on the first step, so for that, we look at it from 6 different dimensions holistically. First and foremost, how is the monitoring of the operations happening? What are the workloads that are failing? What percentage of the workloads are not meeting the SLAs? That's some of the evaluation criteria. When it comes to the cost, what is the cost on the infrastructure? How is the cost allocation happening? What's the cost trend? That's one of the dimensions to look at. The third is on the process itself, right? So the processes that are behind the workloads, are they really architected and designed in an optimal manner? That's important. And of course, the other perspective is storage. And then on the data quality and governance, if you do not have your Unity catalog, if you don't have a view of the lineage, then it's going to be a painful task to really find a needle in the haystack to really identify the problems and fix it. So that is an important dimension to look at. And of course, last but not the least, the performance of the processes and the workloads that are running in itself, right? That's also important. So our framework looks at all these 6 dimensions holistically, and we also can accelerate our framework with our partnership with Unrival Data, where Unrival Data comes, we can leverage their improved observability and the ML-based insights to accelerate our framework and deliver good observability and optimization results on the cloud spend. So if I can just move on here. So talking about observe and optimize, I don't really want to get down to the details of each of these things, but if you look at all those 6 dimensions, there are about 11 core processes on which the evaluation happens. And we're also leveraging Unrival for accelerating some of these processes wherever Unrival has an opportunity to accelerate it. There are about 4 of these dimensions where there is a bit of acceleration that can happen through Unrival. And the other 2 dimensions is where our framework comes in, our expertise comes in. And so together, as a combination of our framework and the tooling, we'll be able to deliver cost optimization and look at optimizing the cloud costs. Now the second tenet that I was talking about, which is on how do we turbocharge performance and slash down the cost. So if you look at this, I think before this, let me go on to the previous slide where there is a view of what that turbocharging performance is about. So NVIDIA's GPU accelerated infrastructure and the Rapids framework that can work on any Spark engine, whether it is an EMR, the Google Dataprog, the Databricks, and wherever that is. So that is being used, the Rapids framework that delivers significant performance boost. And we can jumpstart this exercise by running a quick evaluation utility that really looks at all the Spark logs and then looks at what kind of acceleration is viable, and that can be subsequently followed through with a bootstrap tooling exercise and a POC. Just to show some compelling results of this, so PayPal was able to deliver 70% performance boost and cost reduction through this, and Adobe's Databricks infrastructure was turbocharged 7x times, and the cost was reduced 90% using this GPU accelerated infrastructure and Rapids Spark framework. And we are also implementing this solution at one of our pharma clients to correlate billions of entities in their preclinical processing as we speak. And on the observe and optimize, we have multiple compelling success stories. At one of our logistics clients, we were able to bring down their cost from $1 million to just about $300,000, which is about 70% cost reduction through our holistic framework. In fact, there it was a 4 to 6 months exercise. We did not use unrivaled data there. It was more to do with our framework and going through our rigorous, diligent process of approaching on each of these dimensions. But if you use unrivaled data, that is going to really accelerate this framework to a certain extent. And then, of course, the framework also gives the well-rounded view and exhaustive exercise of optimizing. So just a little bit deep dive into the turbocharge performance and slash cost. You must have seen this graph multiple times when NVIDIA talks about it, right? So when we look at the current cloud infrastructure, just getting CPU accelerated performance is just not going to be good enough. Simply because the performance scaling the CPUs can provide is not adequate for handling the increasing data volume and the complexities in the clusters. So what it calls for, if you just keep utilizing the CPUs, you're just going to be time consuming. Time is money, then you're going to spend more dollars. And then the less time you spend on compute, the less dollars that you're going to spend. So if you leverage GPUs, the computes are super fast and cost effective. So just to give you a perspective on the data volume and what it means to just visualize that, right? If you, for example, let's take a genomics data in life sciences. Google and Harvard Research, they did a 3D map of 1 cubic millimeter of the brain tissues, and the resultant data was about 1400 petabytes. So now imagine what should be the data volume if you were to look at the entire brain, scanning the entire brain, right? So that's going to be in zettabytes. So when you need to draw more correlations like this, a CPU performance scaling is not just going to be good enough, and GPU is going to be a viable alternative. So this is a lightning session. So let's also talk about lightning fast end-to-end performance that we can accomplish using the Rapids and GPU accelerated framework here. So when we look at the ML pipelines, you can see there are 3 steps there on the data load and data preparation, the data conversion, and the XGBoost. So with the chart on the right, it really depicts what are the processing times and the total cost of ownership across CPUs of various nodes and commoditized GPU at the bottom, right? It's very evident that the processing times is significantly coming down just to about 2 seconds to handle 200 gigabytes of data set, and the total cost of ownership is also just about $2 here. So there's significant cost savings here from the GPU as compared to the CPU, and the performance is also going to be significantly improved. So this is a very exciting new model where NVIDIA is charging like very minimal dollars, couple of dollars per hour per workload, and there are also options to lease the GPU, and we are trying this at some of our customers. Right now, as we speak, we have initiated implementing this at one of our large retail customers to incorporate this GPU based infrastructure and the Rapids framework. So not only this, at Cognizant, we are also in the process of benchmarking the data on this framework, and we also have our patented platform called Cognizant's Data and Intelligence Toolkit that has powerful capabilities to convert your workloads onto the cloud. So now, with our partnership with NVIDIA, we are also integrating their evaluation utility along with our conversion capabilities, such that as we convert the workloads, we'll also be able to make that evaluation on what are those opportunities for cost optimization and performance boost. So that's an integrated solution that we can bring to our customers. So what are the simple steps to savings here, right? So that's just a 3-step process here. First one is the qualification. So the qualification is all about using the evaluation utility, identify the estimated cost savings that you can potentially get by running that utility across all the Spark logs, and there is enough viability and justification for the use case, then you proceed with the next step, which is the bootstrap, where we take a few of the workloads, run them on the GPUs, take the Spark logs, and then run them through a bootstrap tooling, and then we give the recommendations on the configuration parameters and other tuning opportunities. And the third step is to look at tuning from additional optimization options that can be possible for final acceleration and look at what are the actual savings here. A POC on this, it can be typically done in about 4 to 6 weeks, and actual scaling of the POC to all the workloads that could be done in pods and phases. Our expertise along with NVIDIA's framework can help us to really identify the optimal balance between the CPUs and GPUs that we can utilize for better spend optimization here. So that's pretty much what I wanted to share here. If you really like what we're talking about here, please stop by at our booth and you can register for a free estimation of some of these tools and offerings that we have discussed here. Thank you.